to class. Last time we covered the waterfall process, which hasn't really been used since about 2000, so it's been quite some time, but by itself. This is still the baseline for how development happens with significant amounts of change. So it's worth going through this simple historical way in order to get a sense of how things are done. We talked about the actual phases. The first was gathering requirements. This just meant that we're identifying the components, the boundaries of where the system starts and ends, what some of the internal components look like in a basic level. But you can see that, you can kind of see that this looks like a hexagon, but not really, and it's not fully filled in, it's not fully fleshed out, because it's just the raw list of features that are written down that are based on some communications that you've had with the client and your first stab at thinking about, all right, what does this client actually want you to make? So you should be talking to the client or customers, whomever this is, as you're figuring out what you need to be doing to get money from them. You build a specification document. You start to move these components that are all around the place. Maybe there are some components that you think of that are outside the specifications a little bit, but we bring them together. Now we have an idea of what we are supposed to be making. A purple hexagon, great, that is the product that we are supposed to create. So your specification document should outline every component of this purple hexagon. Side lengths. How filled is it? What are those components? So you should be thinking about every possible input, every possible state of your program. There should be no ambiguity. If at any point a programmer or a designer comes to you and says, how should this be done? It should be in the specification document. If it's not, you made a mistake creating your specification document. Every single question that you could ask about this product, from how it works to how it's designed, should be embedded in the specification document before we go into how should we build this? What are the specifications of what we are doing? So it's a written document and it should specify how this performs. Not necessarily how it internally works, but how it performs. Every input, every possible state. Covers every possible situation. It's much more comprehensive, but everyone will be on the same page. It is a technical reference for what you are creating. Into the design, we said we're splitting this up now into some number of components. This is really the architecture of the system. This hexagon is built of triangles, independent triangles that are shoved together in a way that makes a hexagon. Great. You have some modules. Those modules, when combined, create the system, but you can also break apart those modules and work on them independently, and also think about how do these independent modules communicate with each other. Because it is so large that it can't be produced by one person, we need to think about what are the components that are in each individual component, the subcomponents, as well as how does the communication happen. We can then break it apart, and individual developers or pairs of developers, if you're pair programming, can work on each of these, and there are distinct boundaries between each of these components. Going and implementing, now you're going to actually create those triangles independently of each other, but possibly there are the same person working on multiple triangles, even at the same time, but they're being developed independently from each other. There are those spaces in between those components, but you are coding. Each of these might be a class or a separate project that will communicate with each other when we build a project made up of sub-projects. So you plan, figure out the order, what are the constraints, what needs to be done before another component, and you're going to start to implement those in an associated order by the priority. This could be something like, how important is it to the client? The necessary features followed by the kind of frills or speed ups. You want the bare bones project to be done first, then start asking the question, how do we turn this into the minimum, from the minimum specifications of what the client wants to something the client is going to be wowed by. It could also be, what are the necessary components for the system to work and be testable? So you get a framework working first, and then you start to fill in from the framework with, all right, we're gonna plug and play this. Now this menu actually opens and I can see it. I can click on something in that menu and it does something. As opposed to just does nothing when you click it, drops down a menu with buttons that don't do anything. You start to implement them from the design down into the functionality. You should be testing each module as you develop it to make sure that it adheres to the specifications. You can look back at the specification document to figure out, does this implementation actually do what the specification document specifies? Once the development is done, you integrate, the pieces come together, and you need to now make sure that you test the entire system, because this is the first time we've been able to test how does a call that goes from the top left triangle down to the bottom triangle, over to the right, the bottom rightmost triangle, back up to the up left triangle. How does that interface work? Does it do what it's supposed to? Because there's been no way to test that before. Finally, we have a product. You do the best that you can. Hopefully, it does everything the specification document says. There may be some frills along the edges that you didn't get around to because there just wasn't enough time. There were technical limitations. You couldn't get the performance quite to where it needed to be to put it in the final product. But you ship it, you're done, and you start maintenance. You wait for the bug reports and you fix the product for the amount of time that you have agreed upon that you're going to support the project.
And make money.
Yes. You actually get the money that has been. If you deliver this to us, we will give you this money. This is the point where you get the money. So we kind of stopped at this point last time. I wanted to refresh you on this because this process is very important to this class and to just development in general. It's very important to know the stages, what happens in those stages, why each stage is important. But note that in a waterfall model, there's no feedback. You go from one stage to the next stage. Once you're done with one stage, you're done with it forever. You move to the next stage, you move to the next stage, you ship, you're happy, you're done. So you test throughout, but each stage leads to the next. And yeah, you test after each phase. If you're familiar with this concept of top down versus bottom up and what that means, top down is you think about the problem and then you start implementing the problem from the abstract design down to the concrete lines of code, rather than bottom up where you start coding and then you figure out, oh, this fits together in this way, and this does, and you figure out the design from the implementation. That would kind of be bottom up, and that would be not great in this system. There are plenty of algorithms out there that work great bottom up, but this makes way more sense top down. When you implement, since you have the design, since it was designed top down, you implement the small components bottom up. So you're going to implement the very small pieces, put them together into something larger. Make the larger piece, it's like constructing Legos. You make small pieces, put those pieces together. You make the subcomponents together make the components together make whatever it is you were trying to make in the first place. So let's talk pros and cons. What can happen? What can go wrong in this idea of a waterfall model? And really think about kind of the lack of feedback between stages and the strict ordering that we have here. Let's go one there and then two in the front.
Any mistake made in a previous stage is going to stay there and then be replicated in the following stages?
Yeah, you can imagine that a mistake was made in your gathering requirements. Does that affect your development? Does that affect the specification document that you create that affects the development? Yeah, mistakes perforate throughout this process.
You do a bunch of like abstraction, such as like trying to figure out what certain parts of the code will do. You can kind of get lost in the sauce, for lack of a better term. You know,
Yeah.
because you're abstracting, being like, okay, this is what I want, this is what I want, this is what I want, this is what the client wants.
Right.
A lot of stuff, a lot of the technical, okay, this is the front facing, but now like we gotta work on the kind of mathematical part of it, and you can lose track of details a lot, with this kind of model.
Yes, absolutely. Losing details. I like taking this back to the comic from the very first day, because every single one of those stages is something that could easily, every one of those mistakes could be easily made in this waterfall model. So lots of risks associated with this. So we need to be able to assess the requirements from the very beginning. That requires the client to know exactly what they want from day one. There's no back and forth. As you start designing, you get some ideas. You take them back to the client. You say, do you want this? Do you want that? Do you want something else? And they may go, I had an idea about this, but that sounds really cool. I can see all the uses of designing it that way. Let's move forward with that. With a strict waterfall, you have nothing. You're going off of and relying on the client knowing exactly what they want from day one. You don't get any feedback from the client until you ship. You pass them the project and you say, this is what you wanted, right? And you hope they say yes and open their wallets. If there are issues in the specification document, you don't find them oftentimes until you're implementing or testing or integrating the components. If the issue in the specification is in the integration of components from the design, then you don't find that until you're days away from shipping. Oops, major debug and code rework that needs to be done, but the client's expecting it on Friday. The entire process takes a long time before you have your first iteration of the project. In fact, the first iteration is the final iteration aside from bug fixing. So you don't really have time. You don't get to see the first working version. You don't get to play with it and find the issues with it from a usability perspective. How easy is this to use? How clear is it? How blocky is that text? Can you read it at the associated distance that you're supposed to be from the screen? These are all kinds of decisions that don't necessarily get caught until way too late in the project. It's very sequential. The programmers are sitting twiddling their thumbs, hoping that there's some other project that they're working on in the meantime, until we've gone through all of the stages to get to implementation. And yeah, this was completely adopted from engineering. The idea is this is how you construct something. If you build a bridge, you go through this exact process. You figure out what needs to be done. You lay out the technical specifications of the bridge. You design the bridge. You build the bridge, and then the bridge is done. And you start maintenance. In 10 years, you come back and realize that, all right, some erosion has happened and I need to fix something. It makes a ton of sense in physical engineering. But does it make sense in the modern code environment? The answer is less and less so every day. But the actual process that we go through is still very relevant. Emphasis on specifications and design and testing, all incredibly important. Communication through documents, so that it's not just he said, she said. I talked to this person, they said this. I talked to this person, they said that. What should I do? There's always a document to go look at that has the answer, regardless of what any person says. And of course, time. The entire design of your engineering process should be about time to market and efficiency, because employees are expensive. The process should be streamlined. You don't want to feel like you're wasting your time. Even as an employee, if you're just getting an hourly wage, you don't want to feel like your time is wasted. You want to have things to do. You want to be making progress. You do want your company to be making money, because that's what's going to be the safety net for your job. The more profit they make, the more promotion, the more money they can afford to throw at you, especially if you're doing a good job. If the project takes a long time, it can be beat to market. It is more expensive to produce just in terms of the hours of creation. So efficiency is very important to build into the process. Also technology. If this is a very large process and the world's changing around you, technology is adapting. your design, your specification and design might be outdated by the time you make a final project. It may be that the technology that you built into your design is completely obsolete. There's a much better system in place by the time your project is done. It might mean that all of the development effort that you put in is completely, no one wants to use your product anymore. Because some other team is working on the new thing and it's gonna be out in 2 weeks. Oops, no one wants to use your project anymore. Lots of third-party pieces, lots of code that you didn't write that is necessary to your code working. Compilers, networking libraries, operating systems. All of these, there are always new ones, changing ones, new languages that are out there, new, more efficient compilers for those languages. If you move slowly, more time is spent keeping up with change than actually actively developing, communicating with the client, doing the actual necessary tasks that will lead to profit. To give you an example of this, and the material that I pull this from is getting more and more outdated every year. California DMV software, this is just a great case study for this. There are many modern examples of this as well. This happens all the time. You try to merge your driver and vehicle registration systems into a new, more modern system. The idea was that all of this migration would take 6 years and $8 million, and they spent 7 years and $50 million before everything they were doing was outdated, a jumbled mess, and it cost way more than they anticipated, and expected delivery slipped 11 years. It kind of reminds you of the north-south corridor a little bit.
I've actually written to our representative and I've been like harassing him. I'm like, at this point, my family jokes about what's gonna come first, me finishing my college degree or this corridor.
Right? Yeah, it's gonna be the degree. I guarantee it.
You can already have 3 generations of people working on the same highway.
Yeah,
It's
They're not-
gonna be the.
yeah.
They're not even working on it, right?
It's, yeah, at the moment, there's a bit of a hiatus due to
They're
funding.
on strike.
Yeah,
Not on strike anymore.
that's back active now.
Yeah, the operator union back.
Ooh.
Did you see the bridge? How beautiful it is?
Yeah.
I think they spent more time decorating it.
Actually, the one person joining remotely said exactly the same thing in chat. The art of the bridge is so. Yeah, there's also with waterfall, if you spend your effort and energy on frills and not necessarily on the usability of the projects, yeah, there's a priority difference or a priority in usability. That if you're not on the same board, if it's not in the specification document and in the design, then you can do things like design a gorgeous bridge before you have a working freeway.
We can, or the projector.
Oh,
It just.
it's sometimes upstairs because the projector is connected directly to the ceiling, which, so yeah, if anything moves there, then it,
Like people walking.
yeah. Yeah. We gotta love this expensive building that we're in. That was very, very well designed for its modern, its current use.
Does EWU own it?
Net or zero.
EWU rents this building for $5 million a year.
Oh, I thought they owned it.
They do not. See, we're on.
5 million a year.
It's supposed to be that zero.
Yikes, my battery is at 33%. We'll see if this lasts till the end of class. I unplugged it at full before my last class.
I've got a charger.
You can also run upstairs if I need it, but I really don't want to do that. All right. So this is gonna be a 4 or 5 part lecture, just going through a few different slide decks. But so we talked about being slow. Waterfall is designed around being slow and methodical, like engineering. But the flip side to this is that what happens if we are faster? So in the short term, in the very near, like the next few weeks, the world is not going to change too much. There's not going to be the next new technology and its adoption rate and So you can start to design and implement around what's happening in a smaller chunk of time, rather than thinking about it in terms of the entire development of the project. So if you're aiming to have faster deliverables, then the planning is also a lot simpler. You don't have to design the entire project from the very beginning. You design, what is the very first prototype deliverable? What does that look like? And you ask the client about the very first prototype deliverable without worrying about all of the frills that they're going to want by the end of the project. You hone in on what is the easiest first thing that I can implement and give you so that you can give me feedback. So waterfall, not so great at speed, but rapid prototyping, on the other hand, is great for this. The idea is, if you've heard of the minimum viable product, this is a concept where if you are the client, you want no bonus features, nothing, just the shell of what the user interface will look like. Nothing does anything, but you get a sense of what does the UI look like. In terms of usability, what is the plan for what something does? That's much easier to create than all of the use cases, all of the conditionals of what happens when I'm on this screen and I click this button, where do I go? What happens if they enter something that's invalid? What happens if a malicious user tries to inject SQL into the login field? What happens if, just start with the absolute bare bones. You don't worry about anything beyond that. You just start with writing the quick prototype. You give it to the end user and you say, what would you change? What do you like? What do you not like? From there, you go back to the beginning of the waterfall process and you can start modifying it or adding to a specification document based on what the client has to say about this rapid prototype. Then you proceed to the waterfall model and you can start from there. So this is kind of a two-pass waterfall. The waterfall for the prototype followed by the waterfall for the main project. What's difficult from here is if you have a prototype, it's not necessarily designed in the way that the full project should be designed. So the right answer is to throw away the prototype and start from scratch. However, this is hard for people to do because you spent time and effort and energy, and we like to think that with a few small changes, this prototype could be the basis for the project. But that lends itself to quite a few issues in and of itself. Those changes are always more complicated and expensive than you think.
Couldn't you just extend and modify the prototype and then use it as your end goal?
You can, if the client doesn't have too much feedback. If they say, yes, I love it, maybe. If they say, no, instead of doing it this way, do it that way. Instead of designing it for this, sometimes the design, the actual design patterns that go into your solution will change based on that feedback. And as we will actually see throughout this class, I will have you be doing some code refactoring based on as the requirements of the class change. The client's going to change their minds on some things. As the project manager, I'm going to say, well, given what the client has said, what if we did things this way? And that will force you to go back, look at your code and change and go through a new design phase of how can we either re-engineer the solution or modify the solution. You'll have to make a tough decision about how much of this project do we keep? How much do we throw away? How much do we re-engineer? So I'm going to put you in that position to have to make those kinds of decisions. And you'll, by the end of the class, you'll have some experience with hopefully some decisions that go well and some mistakes, and seeing the effects of those mistakes on your future workload, on your communication within your team. How does that go? Prototyping as well exposes mistakes. The prototype that you deliver may not be perfect, even as a prototype. You will figure out something like, wow, the performance even of this prototype is garbage. I need to implement something that's significantly more effective.
The prototype of the iPhone had a keyboard, so.
Yeah. Yeah. Imagine if they took that and went with it. It's like, yeah, there's a touch screen, but there's also this little keyboard that we moved to the very bottom and it's not usable, but it was part of our original design that we sent to our manufacturer. So to cut costs,
stick with my hamburger.
Right? So how is this done in reality? Neither of these is really true to real life. You can't do everything in one pass or in two passes, but there are good ideas from both of them. We need feedback at every stage level in waterfall, really. We need to, once we write the specification, we need to go back to the requirements and change the requirement documentation based on the work that we put into the specification. Once we go into the design and we realize what we put into the specification isn't going to work based on the design that we make, you will go back and edit the specification document based on the constraints on the design that you could not think of when you went and made the specification document. When you come into some coding issues, maybe efficiency issues at this stage when you're actually coding and testing, you can go change the design. Maybe new technology comes out. Maybe you realize that this wasn't designed quite as well as it could be. There's feedback to every one of these states. The final product, when you go to deliver it, can lead to an entire new pass through waterfall of, all right, the requirements weren't right. The client doesn't like this, wants some changes. How do we design this with the client feedback? So have feedback loops within waterfall, but also loop waterfall a number of times in order to design something that works. So accept change. As we get to later stages, you may have to go back and modify earlier stages. Plan for that to happen. Don't finalize your documents and print them to PDF. Leave them in an editable form. The entire idea here is to minimize the associated risk of development. Any decisions that you make, you may get more information that changes those decisions later. Plan for that. Plan to get confirmation and reputation, talk to your client, talk to your superiors, your bosses. Make sure that everyone is always on the same page about what you are doing. Don't just have a good idea and run with it without talking to anyone about it. Everyone should always be on the same page about everything. So we still use those same stages as waterfall, which is why I give you waterfall in the first place, so we can analyze what's wrong with it, but also because this is how development is done, just not in a one shot. Iterate the whole cycle over and over and over again, and you can imagine that when we deliver something to the client, this is a build. For those of you who play games, every patch is a build. You've gone through the entire gather requirements. What bugs are too big to fix in a day that need some iteration and further testing? All right, we're going to get the scope of what is the next patch for this game going to look like? What changes need to be made? What balance is off? What are players complaining about right now? What can be done in the next week? That's going to become the scope of the next build. We're going to go through, you gather the requirements by looking at forums, by looking at what people are complaining about. You go into the specifications. You say, all right, how is the game going to work? When this is done, you go into the design. How are we going to implement this? What needs to change? The actual implementation, you create the changes on a test server, not that the players are live seeing. You then go through and you're testing as you go, as you make all of these changes to make sure nothing breaks within the game. And you implement, finally you deploy. And of course that deployment has issues. There are further bugs that come from that. There are further, so you just iterate and you make the next. It's a constant ongoing process. Questions on what an iterative model might look like? In a modern live service game, do we think that 1.0 is the last release, like Waterfall would suggest that it is? You just ship it, and how many games would be successful if that were the case? You just shipped it at 1.0, it's like, all right, I'm done. You bought the game. My work here is done. I'm gonna go work on the next one. What would your reputation be like as a developer or as a company?
I don't know, but that's done.
People still buy the games. It's all your fault.
Let's play Nintendo in the N64.
Yeah, the old video game consoles, that's what you had to design for. But back in those days, what we taught in software engineering was waterfall. Because there wasn't, when you shipped it on a physical disk and there was no, you didn't connect your system to the internet, the full game had to be on the disk. So waterfall was designed for the best experience that you could get in one shot. Because you're not gonna get feedback from anything outside of your development team until it's already out there. So you had to maximize the chance that it was going to be good, that you fixed all of the bugs.
I'm still not about Fallout 76.
The fact that you're in this class, you're taking the prerequisite for my game design 1 and 2 course, so I'll just shout out the advertisement for that over the next couple of quarters. We do more than just design games and talk about games. We analyze games. I want it to be useful regardless of the path in CS you go down. I'll spend an entire class convincing you not to design games for a living. But we'll learn stuff that is useful to you regardless of what you do. So shameless plug, those classes are really cool and fun. Highly recommend you take them. You don't have to. It's up to you. They're electives for that reason. Requirements work the same way as before. Talk to people, the end users, figure out what they want or need, but recognize that the more time you spend talking to them, the less relevant information you're going to gather. So eventually that communication needs to stop because the time that you're spending continuing to gather those requirements is better spent creating a prototype, creating a first usable system, a first deployment, and getting feedback on that. If we were doing waterfall, you would exhaustively talk to them until you understood their entire life story. Because you can't go back to that stage, but because we're iterating this, there's a limit to the value of the information that you get. Get enough to make a workable, usable prototype, then get further feedback on that.
Is there a framework that you particularly use when you're trying to make sure you get enough information, but not too much?
That's a great question. And I think the answer to that is just that if you think about what the specification document would contain, the issue is, of course, if you're thinking about the specification document, you're thinking in technical language, and we'll talk about how to talk to clients because they're not going to understand, oh, so you want me to implement this as a hash map, right? They're going to look at you, blink a few times, and say, I'm going with someone else. I don't like you anymore. You're
Hey,
one of
Professor, I have a
those
question.
nerds.
Is that actually?
Not quite like that, but yes, that does, if the development team is actually communicating in technical language, creating an actual barrier between the client for a non-technical application, then that's an issue. That is a big issue. So diminishing returns, because you can't show them a finalized prototype or a project, you're talking in the abstract. And there's only so much value. Think about when a professor lectures at you in the abstract without using examples or having you work on something. How much are you gleaning from that? That's exactly the situation you will be in when you communicate with a client without the ability to show them something or have them use it and get feedback from actually doing it. So requirements, exactly the same as before. Specification, exactly the same as before, so we still need everything, except that we open it to evolution. You don't finalize absolutely everything, but you take your best darn stab at it. Because the better this document is on the first pass, the better the first product is going to be. The fewer iterations this is going to require, better it's going to be in general. So same thing from design, design for change. Which of these parts are most likely to change? Instead of writing all of the code for what is most likely to change, put abstraction there. That means kind of leave it as a hole to be filled in later. Or put in something that is we'll talk about stubs and mocks and what those mean, but something that just returns false all the time. You don't implement the logic when the logic is likely to change. Yeah. Have a default return value, a default something. Put your effort where you know it's finalized or least likely to change moving forward. And then implement just enough to be able to show this is what this does, but not more than that. So abstraction is still in this place, but now we kind of think of it like this. Now, when we go into the implementation you're gonna start designing from top down and implementing from bottom up still. But you're gonna start planning for incremental development of each module. So instead of just making every single triangle, you're gonna just implement the tip of the triangle and plan for that implementation. There's a lot more that goes there, but you don't need it all right now on the first pass. You just need the most critical components for testability, for usability, to get the most information that you can from the client with minimal work. That's actually a good question in chat. NASA's still using waterfall. And yeah, there is still engineering that is needed when you kind of have a one shot, something like sending a spacecraft out into space, where maybe you can reprogram it remotely, but you need waterfall on the engineering of the design on any code that can't be remotely modified or changed. So yeah, there is still certainly a place for a style of development like that.
Did you hear they did a hot patch on Voyager?
Oh yeah. Yeah, I think I did I read about that, but I don't know too much about it.
It's impressive, the code change from trillion.
Yeah, yeah, it can happen. The technology is starting to be there.
The latency ping of what was it like?
24 hours.
Yeah.
Every single, I couldn't do it.
Around the Earth, 6.5 times per second. 24-hour ping gives you a sense of scale of that distance. So yeah, iterative implementation of individual components. So that's the design. You're designing for implementation 1, implementation 2, implementation 3. But this is not actual implementation yet at this stage, really. So build 1, you'll get the skeletal system working. So build 1 really just kind of looks like this. This is what you ship to the user on the very first pass. It's just the skeleton. These are the boundaries, right? You can now not really play around with, but you can see what's in and what's outside of the scope of the project. Every single build starts to add just a little bit more functionality at a time. So you start with the innermost components, maybe that's a build. And now the end user can play around with, okay, these components that are around the center, the most important components of the system, I can actually see how they work. I can put in the queries. I can see the results. Each build, more and more functionality over time until you get to the part where you're ready to now integrate those components. Note that you're not necessarily integrating until the project is done. That's a big design decision for any given project. Do you design, implement, integrate, ship, and then continue to do that? Sometimes you need to do that. Or do you slowly design each component and integrate once at the very end? So eventually you reach a stabilization point where the entire application works. And that's where you ship that version of that or go get feedback on that or show it to the client. Then you go back through waterfall again. What's wrong with this? What are the next most important features that you want to see? Let's go edit the specification document, design a solution for that, implement that, integrate that, get feedback on that, loop it. So advantages, you get very early feedback from users, which is incredibly useful. You get feedback on whether the specification and design are even feasible. Is this what the client wants? Is it technologically possible? It is a bit more quantifiable if you break this down into development sprints, where each sprint lasts 2 weeks, like they will in this class. You can get a sense that, all right, when 3 of 4 sprints are done, we've built the project 3 times and gotten feedback from the client 3 times, and there's 2 more weeks of development left. The project is about 75% complete. Whereas in waterfall, when we're in the implementation stage, how close are we to done? Who knows? It's not really quantifiable very well. Some disadvantages: if you make a major mistake in requirement specifications or design, you may have to completely re-engineer your solution. A lot of the cycles that you've gone through are now invalid or need to be completely redone, or massive code reworks still need to be done. We don't invest as much time before build one, so build one doesn't get you as much information as it would have otherwise. You're also starting to implement before you understand more than just the outlines of those triangles. So coders might not have a full grasp of all of the technical limitations of everything that they're going to be doing eventually. Issues like that. But in general, it's better to get something working and to get feedback on that, which is why we typically do it that way. It's better to get something working and get feedback than try to do it in one shot or in a prototype shot and an implementation shot. It goes better. So in practice, there is some kind of iterative model. In most professional software, there are daily builds, something like Outlook as a daily build. The system is always working, you're always using the most up-to-date build. You're going through an entire waterfall every day in terms of figuring out what can we do today to make changes to this system in a way that will improve it. So Microsoft does this. Of course, if it's hard to test, as mentioned, something like NASA, you may need to revert more closer to the waterfall model if it is difficult to test and iterate and get feedback on. So summary of everything from this. Good processes are vital in software engineering. Waterfall, great start, but we've moved past that. We've evolved from the waterfall days to iterative processes, and we're going to augment these iterative processes with agile development, and that's what we're going to talk about next. Is agile. We are down to 6%.
The office, I believe in you.
All right, let's go grab that one. Didn't necessarily think we'd get this far, but that's great that we have.
That shape was
All right. We need to get through this discussion before we can start this project. And the reason is this is how agile software development begins. This is how communication with the user happens and how you convert it into technical processes that you will go implement. So user stories are the beginning of this, and they're going to be the first actual deliverable from your project. So user stories are historically, because development happens in a room together with your coworkers, written on index cards. In today's day and age, they're written on a Kanban board or GitHub tasks. So you're going to start writing down user stories. You're going to deliver a list. Once you have a Discord, there will be a channel for user stories. The idea behind this is it is a feature in client language that your project needs to include. That means that there is nothing technical about it whatsoever. So a meaningful title, what that feature is, a customer-centered description of what it does and why it's useful to the client. And we'll talk about exactly the 3 lines they contain. You don't necessarily have to have all of the stories in the first iteration, but it's useful to have all of the stories for a particular sprint embedded within that sprint. And I will give you the associated layout for that as we cover the first sprint. As an example, let's give you the 3 lines. The CEO comes to you and says, I need accounting software. And when I use it, I can create a named account, list the accounts, query the account balance, and delete an account. Some user stories for this might look something like create account. It's a meaningful title. The description of it is, I can create a named account. List accounts. I can get a list of all accounts. Notice how this is not technical at all. It doesn't tell you how that's going to happen. That 6% evaporated. Wow.
How many is that?
2 years.
I think it's Windows 11, like literally every machine I've ever had.
It's super warm. All it's doing is running PowerPoint
What kind of laptop?
and Pro. It's so more just like so. Let me, I can finish off a good chunk of this lecture, or at least make the time worthwhile until we have to go. We only have a couple more minutes, but let's stick with it and I can talk about what a user story, or a good user story contains.
Yeah, you can also,
So we have title, description.
they let them go, they didn't want to service this.
So this description, even on those, was a little vague. So it's useful to, from the client's perspective, use a little bit more specific language. So crap, what I think that's I want my slide. I would rather not mislead you by making any mistake on this. I could bring it up on this and share this, but we also have literally 2 minutes. Let's see if I can do that. This is gonna replicate too, isn't it?
So I figured we would be thinking because when you typically tells us.
Yes.
So making these.
So, yeah, I will give you the first sprints requirement. Maybe I can spend a talk a little bit about the project, but we will probably do a little bit of this at the start of tomorrow's lab. But yeah, I'll give you the first sprint requirements. Tony's not going to come in and do that, but I will say, I talked to the client and we'll play a little game of telephone. I designed the whole project from the beginning, so there's no information lost from that. But yeah, I will be giving you the requirements, both the technical and non-technical requirements, so that you can do that, but it's worth going through and building those user stories as a sense of, it ends up being just you take those user stories from the client language, you turn them into scenarios. We'll talk about those. Those scenarios are more of how something works. When I'm on the screen and press this button, I end up here instead of, and that's not necessarily client language, but it's more from a usability perspective. Then from there, you go to the technical tasks, and that becomes what needs to be implemented. You pull from that as you implement, basically. But we'll get a little bit more of that now that we're a minute out. I don't feel quite so bad. It's just gonna have to be authenticated. It's gonna take too long. So we'll come back tomorrow for our lab, plan for the lab, go over this a little bit, talk about Git and GitHub. I will give you a small GitHub assignment from a site that I use for learning and understanding Git branching. I'll talk about Git flow, exactly what that is and the requirements for using Git and some pitfalls that I see for Git. So that's incredibly important for everyone being on the same page about how you start with Git in the class. And then we will go into the technical requirements for the first sprint and possibly get a chance to start on some design.
Are we meeting in 219 tomorrow?
Yes, yeah. So yeah, starting tomorrow, labs will be in that room. There's a little bit more whiteboard in there. There's a little bit better. You can work on the machine and start implementing there, so you don't have to bring your own machine. And I will divide up into all of your associated groups, give you a pane of whiteboard space, and you will be designing on that as I go around and talk to you about that design as I introduce you to the project. So we're going to start kicking into high gear starting tomorrow.
So tomorrow we're not gonna be in this room?
Right next door. It does still say that.
It says 320.
Yeah, I checked and made sure with Jane that room is free.
Okay.
And it's much better to be in a lab. I wanted a lab this class, and then when they give it to me, of course, they don't listen.
Oh, so we're gonna be always there.
Yeah, Wednesday afternoon is always just next door.
Yeah.
I'll give you an extension.
Yeah.